All right, this is our lessons 5 and 6 review. So 1 through 4 are all adding, subtracting, multiplying, and dividing, combining like terms, the distributive property, all that fun stuff that we know how to do. So I can see on number 1, they're asking me to subtract f of x and g of x. So I know that I'm combining like terms. If it helps, write them out. 3x minus 2 minus, be careful with your negatives, x minus 3, right? We have to be careful that we're subtracting appropriately. So yeah, that's why I put those parentheses there. So this one is super easy, combining like terms. I see I have a 3x and a 1x here. 3 minus 1, again, because you're subtracting, is 2x. And so this next one's where we got to be really careful because it's negative 2 minus negative 3. And if you do negative 2 minus negative 3, that's really negative 2 plus 3, which is 1. So 2x plus 1 is f of x plus g of x. So that one, this is the solution to number 1. Number 2, you're adding, which quite honestly is easier, and I'm not going to bother writing it out because I don't have to worry about my signs being weird, right? So here I see I have a negative 5x and a 6x. So I just need to add negative 5 plus 6, which is 1. So 1x. And then here I can see that I have a negative 4 and a negative 7. And negative 4 plus negative 7 is negative 11. So that's f of x plus g of x. Super duper easy. You're just combining like terms. Watch your signs. There we go. There's the solution to number 2. Number 3, you're going to have to do a little work here because it is the distributive property, right? You're being asked to multiply f times g. So that means on this one I'm going to do 3x plus 2 times 7x plus 6. Okay, so actually I'm going to change, okay, I already got that. What is it? 3x plus 2, 7x plus 6. 3x, oops, plus 2, 7x plus 6. Again, I'm multiplying them together. So this is just the distributive property. We've done this 20 times. 3x times 7x is 21x to the second. 3x times plus 6 plus 18x. Do the same thing with the 2. 2 times 7x is 14x. And then 2 times 6 is 12. So I did the distributive property, and then I can see here on this one that obviously I have two like terms, right? Positive 18x plus 14x. I can add those together. So the solution for this one is going to be 21x to the second plus 32x plus 12. That's the solution for number 3. So I'm not going to bother writing that up in number 3 because hopefully you have it now. Number 4, so this one I'm obviously dividing. I can see that because you're dividing. But this is the one where you don't actually divide. We're going to have to factor this one. So again, I'm going to write it. So notice f is x squared minus 16 and g is x plus 4. So x squared, I said x squared and didn't write it. Oops. So x squared minus 16 over x plus 4. All right, so this one's factoring is actually pretty easy. The numerator, that's the difference of two squares. Remember we talked about how since x is a perfect square, that's going to become an x and an x. 16 is a perfect square, 4 and a 4. And it's always going to be adding and subtracting. We did that several times. If you need clarification, make sure and ask. And in the denominator, we're going to have x plus 4. Right? So if you remember what happened in class, is like this divides out with that, right? They're the same. They divide and equal 1. So your answer for that one, I guess I just can keep that color, is just x minus 4 because that's all that's left of my function after I simplify it. So that, after I divide and simplify, is the solution to number 4. Pretty simple. All right, let's look at number 5. Number 5 is they're asking you to do the composition. That's what it means whenever it says, what is the rule for the composition? Now notice they want me to do g of k. Remember how I talked about you can also write it like this. And I personally like that way because my brain sees, hey, I'm going to take this k function and put it into the g function. Again, you don't have to write it like that. I just personally like that. So what that means is I'm going to take this k function, which is the square root of x minus 9, and I'm going to put it right there where that x value is. Remember, it's like substitution, kind of. So what we end up with is, I'm going to write it down here, 4, and then the square root of x plus 9 squared plus 2. Scroll back up, make sure you understand where I got that from. I did 4, and then instead of just an x, I put that x minus 9. I need to go back and change that, don't I? Squared plus 2. Okay, so this got changed with this. And again, that should be x minus 9. I put x plus 9. Sorry about that. X minus 9. There we go. I do have to simplify this, but as we talked about many times, we know that squaring a square root cancels it out. So this is just going to become 4 times just a regular x minus 9 plus 2. Again, the square root and the square cancel each other out. I will be doing the distributive property. That's going to give me 4x minus 36, because 4 times 9. And then the plus 2 is still there. And then obviously my two numbers at the end, those two constants, I can combine those. Negative 36 plus 2 is going to be 4x minus 34. So that is the composition rule for that one. All right. Wow, number 6 is so easy. I like this one. So for number 6, you're finding g of f of negative 5. Remember how we talked about you want to work backwards. Put the negative 5 into the f function first. So I can see here the f is x plus 2. So the first thing I'm going to do is negative 5 plus 2. Again, that was f of negative 5. Let me write that so it's easier to read. F of negative 5 is 5 plus 2. Excuse me, negative 5 plus 2. Which, of course, is negative 3.
Miss West right. And Miss Taylor's back.
So that is negative 3. All right, we just put the negative 5 into the f function and got negative 3. Now we're going to take negative 3 and we're going to put it into the g function. Here I can see the g function is x to the second. Be careful with your sums, because if I do g of negative 3, in my calculator, I need to make sure and type in negative 3 squared, or just remember, anytime you square a negative, it's a positive, because the answer to this one is 9. That's the solution to number 6 is 9. Number 7 is relation t a function. So I can see here how all of my x values are different, right? 0, 2, 4, 6. Those are all different numbers. So the answer to the first part of the question is yes, it is a function. Then it asks, is the inverse a function? Okay, so if I were to write the inverse, which I'm about to do, that means I'm going to trade the x value and the y value. So that becomes negative 8 and then 0. And then negative 7 and then 2. And I'm totally going to run into this, sorry. And then negative 4 and 4. And I'm going to do a little bit of erasing right here, sorry. Hopefully you got that written down. Negative 4 and 6, right? All I did was I just switched these two, because we talked about many times that's really all inverse is when you switch your domain and range. So that's the inverse. However, I can see right here, oops. Sorry, a little technology issue there. As I was saying, the inverse for number 7, I know is not a function, because negative 4 and negative 4, those are now my new x values, and of course they're repeating. I have two of them that are the same, so that means that no, the inverse is not a function. So is the original relation a function, is the inverse, and then you have to be able to tell me what the inverse is. Sorry for the pauses. Okay. All right, so number 8, they give us the graph of this lovely parabola, And I can see here that the parabola goes through. This is the point -2 and 3. And I can see here that this is the point. I'm looking for points that obviously exactly go through and aren't fractional or decimal. So that's -1 and 0. This point down here, this is 0 and -1. This point over here is 1 and 0. And this point right here is the point 2 and 3. Okay, so the reason I wanted to do that is just like how we talked about in class the other day and how we just did on number 7. I know that the domain and range switch. So what I'm really about to do is I'm about to take these points, and I'm going to list them over here on the right-hand side so you can see. I'm going to switch them. So like -2, 3 becomes 3, -2. -1, 0 becomes 0, -1. 0, -1 becomes -1, 0. They basically just trade places. 1 and 0 becomes 0 and 1. And then 2 and 3 becomes 3 and 2. So I just kind of like the table that I just did on number 7, my domain and range, and switch. All right, so let's see what we got. 3 and -2 is here. 0 and -1 is here. Remember, we will have some overlap, and that's okay. -1 and 0 is here. 0 and 1 is here. And 3 and 2 is here. So what's happening on this graph is my parabola basically just turned sideways. Y'all know I can't graph on this thing. Like this. So that's the graph of my inverse, is that green graph. And then I ask, is the inverse also a function? Well, I can see that it's not, because even if I look at my list of points, and that's actually pretty helpful, I can see here, like, look, the zeros repeat. So immediately I know it's not. I can also see, gosh darn it, that the 3's repeat, right? So I have repetitive x values, kind of like what happened on the last one. So the inverse is also not a function. They are sometimes, but this particular one happens to be not. All right, number 9 and number 10, we're writing the inverse, of the relation. I can see here they're both already y, so it's nice and write f of x. So these are just like the ones we did yesterday. Number 9, I'm going to do it down here, 7x squared minus 3. Let me make that smaller. Y equals 7x squared minus 3. That was the original problem. Let me make sure, because you guys know I have a tendency to mess up. Here we go. All right, the first thing I want to do is I want to switch my x and y values. So that's going to become x equals 7y squared minus 3. All right, so switching our x and y values. Again, you're trading your domain and your range. And then now I just want to solve for y. So I would add 3 to both sides. So that's going to become x plus 3 equals 7y to the second. Again, we're solving for y, so then my next step would be to divide by 7. I'm going to leave that as x plus 3 over 7. Not really a lot to do there. Of course, these two divide out. These two canceled out also. I get y squared. And then I want to get rid of the squared, and I know the opposite of squaring something is taking the square root. Oops, wow, sorry about that. So I would take the square root of y squared and then take the square root of x plus 3 over 7, which means that my inverse is y equals the square root of x plus 3 over 7. But remember how we talked about we want to write it in that proper inverse notation. So the inverse of f of x equals the square root of x plus 3 over 7. All right. And really, number 10 is the same thing. It's actually a whole lot easier than that one. I'm going to actually work number 10 right here. It's that pretty. Same thing. I'm going to switch. This becomes x equals 3y plus 9, switching my domain and range. So really, all I have to do on this one is like subtract 9 on both sides. All right, so this is going to give me x minus 9 equals 3y. And then divide both sides by 3. Now really, if you were really feeling it on this one, okay, so again, these two subtract out, these two divide out. You could do something to this one, but we've been leaving it in, in these fractional terms. So we're just going to leave it as x minus 9 over 3. or again writing it in the inverse of f of x equals x minus 9 over 3.